Hi, this is Swathiramya, Assistant Professor, AIDS Department. In this video, we are going to do a small activity, that is case study by my students. Today's topic is on deadlock. Deadlock is a situation in a computer system where two or more processes are unable to continue because each one is waiting for the resources held by the other process. As a result, none of the process can proceed and the system becomes stuck. Let's understand with a simple example. Imagine the two students sharing two resources like a printer and a scanner. Student A holds the printer and waits for the scanner. Student B holds the scanner and waits for the printer. Both the students are waiting for each other to release their resources. Unfortunately, they could not able to get the resources at any time because neither releases it and no one can continue their work. This situation is called deadlock. Let's see what is the problem statement and the case study. Priya is going to talk about the deadlock case study. That is, she is going to explain the problem statement on the deadlock.
Myself Divya from the Department of CSE. Hello everyone. Today I am going to explain a case study on deadlock in operating system using the design thinking approach. In modern computer system, multiple programs run at the same time and share limited resources such as memory, printers and the files. Sometimes these programs compete for the resources, which may lead to a serious problem called deadlock. Deadlock occurs when two or more processes are waiting for each other to release their resources and none of them can continue their execution. As a result, the entire system may stop functioning properly. Understanding the deadlock and finding the solution for it is very important in operating system and design.
Well explained. She explained very clearly about the effect of the deadlock, how the deadlock able to stop the working of complete system. Let's hear what will be the empathize of the problem statement. Now my student Akila going to explain the empathy part of the case study. Let's hear from her.
Hello everyone, myself Akila. I am currently pursuing certificate degree computer science engineering. The first stage of design thinking is empathizing with the problem. In this stage, we try to understand how the problem affects the system and its user. Imagine a computer system where several users are running. Imagine a computer system at the same time. For example, one program in different program at the same time. Another program using a file. If each program requires the resource held by the other program, they both start waiting for each other. Because of this waiting condition, none of the program can continue. This situation not only slows down the system but also affects the user experience. Users may notice that their programs stop responding or take a very long time to complete. Therefore, understanding how deadlock affects system performance helps us identify the importance of solving this issue.
She clearly explained how the deadlock affected the performance of the entire system and this issue to be solved. So let's hear from her. Now Deepika is going to explain about the defined part of the case study. Let's hear from her.
Myself Deepika. I am currently pursuing the Computer Science and Engineering at SNS College of Technology. Now I am going to tell about the next step is defining the problem clearly. Deadlock occurs when process cannot proceed because each one is waiting for the resources held by another process. There are four main necessary conditions that occurs in deadlock. There are mutual exclusion, hold and wait, no permission, circular wait. Now I am going to explain about the four types clearly. Mutual exclusion. A process can be used by only one process at a time. Hold and wait. A process holding one resources may require additional resources. No permission. Resources can be taken away from the process forcibly. Circular wait. A circular chain of the process executed where each process waits for resources held by the next process. When all these four conditions occurs together, the system enters the deadlock state. For example, condition 2 process A and process B. Process A holds resources 1 and waits for process 2, while process B holds resources 2 and waits for resource 1. Since both are waiting for each other, neither process can process.
Well explained. Deepika clearly explained what are the conditions, what are the reasons for the deadlock to occur. Let's hear more about it. Now my student Ashwata is going to explain about the ID part of the case study. Let's hear from her.
Myself Aswata, currently pursuing second year BCSE at SNS College of Technology. I am going to explain about the idea problem. In the ideation stage, we brainstorm possible solutions to prevent or manage deadlocks. One approach is deadlock prevention, where the system is designed in such a way that at least one of four conditions cannot occur. For example, a system may run a process to request all the resources at the beginning. Another method is deadlock avoidance, where the operating system carefully checks resource allocations before granting request. One well-known technique is the bandless algorithm that ensures the system always remains in a safe state. The third method is deadlock detection and recovery. In this approach, the system allows deadlocks to occur but detects them periodically. Once detected, the system can recover by eliminating one or more workload or by releasing resources.
Instead, she clearly explained what are the ways we can able to control the deadlock system. That is, prevention is always better. She told what are the prevention way and what are the recovery way. Now we are going to discuss about the prototype that we needed for this study. Divya will explain the prototype part.
This is Divya, and I am here to explain the prototype model. In the prototype stage, we implement possible solution in a simplified system. For example, the operating system may use a resource allocation algorithm to manage how the process requests and release the resources. One prototype solution is implementing a scheduling mechanism where the processes must request resources in a fixed order. This reduces the chance of server waiting. Another prototype is adding a monitoring system that tracks the resources usage and identifies the potential deadlock situation before they occur.
She clearly explained what are the way we can build the prototype. She clearly told that we need to take a resource allocation algorithm in the best way so that we can avoid the deadlock. And also monitoring system has to be focused to reduce the deadlock or to identify or before getting into the deadlock, we need to know about whether it is going to cause a deadlock or not. So these two systems should be focused to define the prototype. Let me conclude the case study. From my student's point of view, deadlock is a serious problem in an operating system where two or more processes wait for each other's resources and cannot continue their execution. This causes the system to stop responding and reduce overall performance. Therefore, operating system must manage the resource very carefully using the techniques like deadlock prevention, avoidance and their detection, and also the recovery. By handling the resources properly, the system can run smoothly and ensures that all the processes complete their task without getting stuck in the deadlock situation. Understanding and solving the deadlock problem helps to have the operating system in an efficient way. Thank you.